All right, so yeah, definitely a good idea to start making a group chat. But what you can all do is actually email each other in the Canvas message, the Canvas inbox. You can send messages in the Canvas inbox to each other. So that will be good. So welcome everyone to Chem 1A, day 1, lecture 1. I am happy to see everyone here. Let's see how many people. Good, we have 32 people here. That's about half the class. That's great. So welcome to Chem 1A. I'm Elizabeth, and you just call me Elizabeth. You don't have to call me Miss Flynn or Professor Flynn or anything. Elizabeth is fine, but yeah. And let's see. So what I would like to begin with today are a couple of announcements. So at the beginning of class, we'll always take the first few minutes to go over the announcements that I have posted on Canvas, and they posted at midnight, but those were the wrong ones. I have the correct ones up now. So let me share my screen and show you announcements. Okay. So here's where I'll be posting lots of good information for you, for our class, for things going on in the college, otherwise, equity at West Valley. And so be sure to set your Canvas notifications and check your email every day. That's the #1 thing I want to remind students about. So we have a page, the Getting to Know Canvas or the Getting Started with Canvas page, right, in the week 0 orientation module that shows you how to set your notifications in Canvas. So that's really important. And here's also a link to learn how to forward your email, your college email, to your personal account. That's another way to make sure that you're on top of your emails. Okay, so chat, yes. Okay, so yeah, so all right, so cool. All right, you can figure that out later, and great. So we have our Dean of Science and Math holding student hours today for 9 to 3 on the 31st, and then also tomorrow from 1 to 3 in the Caranium Cafe. So she'll be available for you to answer any questions you might have. Just another resource, someone else to be able to reach out to and get your questions answered in this first week here. And here's her email. We also have our very own counselor, Claudio. I've met him a couple of times, and he seems really great, really just wants to make sure any questions get answered, any help you ever need with anything in your STEM major, your STEM classes. We have our very own counselor. So you can also access his counseling schedule through Cranium Cafe. Cranium Cafe is like the online hub for support at the college in these times of not being able to meet each other face to face. And he'll be available most mornings and afternoons. And hey, Women in STEM Club, there is going to be a new club formed this semester. I think it would be great for people to join this club, Women in STEM. There's also a Women in Science and Engineering, Women in Science and Engineering club that is nationwide, and this looks like it's going to be at West Valley College, and so it'll be held on Thursdays at 7:30 p.m. That's a nice accessible time for meetings, and you can contact the email right there for the Zoom link. And we need a note taker in this class for disability and educational support program. We need a note taker. So if you're a note taker, you'll receive priority registration. You'll receive a letter acknowledging your community service and a Barnes & Noble gift card. So let me know after class if you're interested, if you take really nice notes, and you can share those notes with someone who needs them for their accommodations. So what questions do you have? Anything about the announcements?
Not about the announcements, but on my West Valley portal, it says that I'm in section 74177, but on Canvas, it says that the section number is 74137.
Yeah, the name of the Canvas is just that. I don't know why, but okay, that's just the name of the class. But you're both embedded. You're both merged into one shell.
Okay, awesome. Thank you.
Yeah. Cool. So great. I'm glad you're interested in setting up a group. You know what you can do? Yeah, you can use whatever you want to do, but also you can Canvas inbox each other. So on your Canvas inbox, you have the ability to send messages to each other. So that's always another great way to get in touch with everyone. So I'll get to the chem kit in a second. Anything just on the announcement. So let's like go through and I'm gonna do like the overview a little bit. But yeah, chem kits are gonna be available. I don't know when is the thing. So it all just depends on when they get delivered. So I'll be keeping you you know, rest of that information and everything about that. So no, so let's go to, hold on. So let me go into Canvas again. I will share my screen again and we'll kind of go over the, you know, the workings of the class and like how everything is set up, okay? So I'll share my screen. Okay. So let's go to about our class because that tells you about when you go to lab and when you go to discussion. We're going to see that video in a little bit. All right, so lectures, again, are asynchronous. I'm glad to see everyone here. You don't have to be here. You can watch them later. I will be posting all the recordings for Mondays and Wednesdays, okay? And then down here, discussion is on the day that you normally on the day that you don't have lab, right? And lab, that Monday or Wednesday down here, that's what you see in your schedule. Like that's what you registered for. If you saw Monday in the course catalog, then that means Monday lab, right? If you saw Wednesday in the course catalog, that is Wednesday lab. So the 7-7, the 74177, that's Monday. And then the 37, the 74137, that's Wednesday. So let's see. Lab is synchronous as much as possible. I understand that there's reasons, excusable reasons that you might not be able to meet lab, right? To make lab. And that's okay, just ask me ahead of time. And I've already given some excused absences for lab because I'm going to be posting the recordings anyway on Canvas. And so again, I want to allow for people who, you know, if you get sick, I want to make sure that everything's okay and that you're able to access the information that we go over if you're not able to come, okay? And yeah, the discussion section. So again, that's normally on the day you don't have lab, but everything's in your calendar too. So I made it so that each section has their lab in the calendar here on Canvas and their discussion on the other day on the calendar here on Canvas. Lecture is both days for all sections. And so yeah, so you can always go in your calendar and get reminded of when you're supposed to be where too. And discussion is going to be, it's just an hour. So really we just do some practice. We might, like today, what we're going to do is kind of continue going more in depth over some of the lecture topics that we go into today. And we'll do problems together, we'll do examples, and then you will be submitting a discussion assignment based on the Zoom meeting. So that's also posted in week 1 right now. Questions so far about your scheduling, when you need to be where? Anything here so far?
I had a quick question.
Hold on, do you mind, would you mind typing in the chat your questions, please?
Oh yeah, of course.
Let me get the chat though, it's not showing up. Okay. Yeah, so the chem kit will be required. Let me know if you're not able to pick it up though, and I will find a way to get one to you. So here in lab, this information here, the take-home chem kits will be available. I don't know when yet. They need to arrive and everything. I need to put them together, but I will be doing that. And so you'll have hands-on experience. You'll get your own glassware. You'll get a scale, and you'll get some pH paper and some different chemicals. And yeah, so other questions? Yep, we're having lab today. Monday lab section begins today. Yep. And okay, so I thought I had answered, Kobe, I thought I answered you for your ad code. I thought I sent you another one, right? Because the one didn't work, the zeros in it. Was that you? I thought I had sent you another one if you didn't get it. None of them worked. Okay, then what section are you? Maybe it's the wrong section. Email me again. Yeah, if it wasn't, maybe the section's off. So email me again, Kobe.
I will. Yeah, I'm looking for section 74137 is what it is.
74137.
I'm sorry.
Oh, then the 37, those were the wrong ad codes. Okay, so I gave you the one for 77 because I thought you were looking for Monday.
It's the Monday lab and lecture? Yeah.
Well, Monday is 77.
Okay, so then yeah, that's the one I believe. I apologize.
Right, and those are the codes I did give you. So make sure you're going in and registering for the Monday 77.
74177.
Yeah.
Okay, my mistake.
No problem.
Okay.
Good. Glad we got that figured out.
Thank you.
Okay, I don't know when the chem kits are going to be available. I don't know because they haven't arrived yet. So I'm really hoping that they arrive in the next, like at the end of next week, so I can get them set for you to pick up like over the weekend, like next weekend. That's what I'm hoping for. But I don't know yet. So I will definitely keep in touch with you about the chem kits, okay? So is that Param? Is that how I pronounce your name? And seven.
It's Parham is the easier pronunciation.
Can you say it again?
Parham.
Parham. Okay, great.
Yeah.
And
It was for the 74177 section, so that's today, right?
77 is Monday today. Yes.
Oh yeah. The ad code you provided, it said it doesn't work.
And which one did I give you?
I believe the ad code was 707 MF1.
Yeah, and it didn't work.
It did not work. It says invalid authorization code does not exist for CRN.
I'm not sure about that. Then why don't after class we'll figure it out, okay?
Okay.
Okay. Yeah. Yeah, the ad codes are for people on the wait list, or if you're trying to add because the ad register window has closed. So if you're trying to add at this point, you need an ad code. But if you're already registered, then you're good.
And this may be an odd question, but today's the first day, right?
Yes.
Okay, because when I was trying to register it, I was already asking for an ad code when others would just be waitlisted, so I was confused thinking this one had already started.
Okay. Yeah, this is the first day.
Awesome, thanks.
Okay, you're welcome. All right. So let's see here. Continuing on Canvas, so this is the About Our Class section. So I'm going to assume that you have, if you're enrolled, that you have already gone through week 0. If you haven't, that's okay. But make sure that you do that soon, right? So we are continuing. This is week 0 syllabus module. So I don't have an actual syllabus like on a paper or anything. It's actually just embedded with within all these pages, right? On Canvas. So I'll show you where I'm coming from, right? When we go to modules, right? The week 0 orientation / syllabus module, right? So you're starting here, you're going through all of these pages, right? So we started just then on the About Our Class. And at the bottom of each page, you can click the next button. And this is on a browser. If you're on your mobile device, it doesn't say next, but there's just a little arrow going to the right. All right, instructor contact, here I am. Here's my bio. You can read that, read about me. Here's a picture of me taken this summer at Yellowstone. Yellowstone is like my spirit park. That place was a geothermal wonderland. It was so amazing. I cannot wait to go back. It was the first time I had been there. So here are all the different ways you can contact me. Oh yeah, our open hours are, I'm going to be changing this, but open hours are on the calendar and they're going to be right before lecture. That's the time that I have. Later on in the semester, if it seems like a different time would work best for more people, we can talk about changing it. But right now, the only time I have is 10 a.m. before lecture, from 10 to 10:45. So I'll be changing that here, but that's when you come and meet me face to face. That's how we can, you know, get to know each other, and you can ask questions about the class. But really a good thing about open hours is just getting to know each other and form a relationship, because that way we can build a learning partnership and work together on your goals in the class. So I'm going to be I'm going to be contacting you via announcements each week, each beginning of the week, and then I might make a modification toward the middle of the week. And then Canvas inbox as well. So that's how I can most easily contact all students at once. And so make sure, again, that your notifications are on for Canvas, inbox, messages, and announcements. Here's how to do that on the next page here. Setting your announcements, or rather setting your notifications on Canvas. Also, I recommend customizing your account, giving yourself a profile picture. You can change your display name. You can put your pronouns in there too. And you can also change the ways of contact in your profile. Here's how to set your notifications. You can click this link here and see how to do that. And there's a help button, right? On the side here, if you're on a browser in the app, here's how you can get help if you're on Android or iOS. Okay, here's mobile help as well. Here's videos of how to get acquainted with the Android Canvas app, as well as the iOS Canvas app. And then here's a Canvas overview if you're using a web browser. Okay, if you're not, you know, super, you know, expert at Canvas, which, to be honest, like, it takes a long time to get to know the ins and outs of it, and I don't know the half of it, I'm sure. So questions so far about getting set up with Canvas or how to contact me? You can type your questions in the chat. That is how I'm going to prefer to have contact between myself and everyone in this class during lectures, is in the chat, and we'll talk about that in a second, my expectations. Okay, so definitely setting notifications and checking your email every day as well. All right, so let's see next. Okay, discussion tips, you can check those out. We'll be submitting discussions, getting to know each other. There's also that Q&A discussion. Here's the icebreaker discussion that most of you have already submitted. Many of you still have to do that. Lots of people have replied. Okay, so equity and learning partnerships. Here we are. I'd like to take a minute to talk about this stuff here. So our learning environment, I understand, I like equity, like I said in my welcome video, is so important to me. It's at the forefront of my teaching, and especially equity in STEM, equity in chemistry. And what that means is reaching out to students who have been historically, traditionally, or if they're from, you know, historically or traditionally racially minoritized communities or minoritized communities that have not received the same resources that white communities have. And so I, you know, do a lot of work outside of class. I do a lot of learning about myself and confronting my own implicit biases, because I think that that's where it, you know, starts, this work on beginning to, you know, achieve equity in STEM, in sciences, and in education in general. So I recognize the benefits gained from personal experiences, values, and views of diverse groups of people. Also, I believe that these perspectives are critical to a well-rounded class, a learning environment that is most conducive to support and connection in together in our class. So if there's any suggestions that you have about other ways to include the value of diversity in this course, they're welcome. If you notice that I have done something or said something that makes you feel uncomfortable, or if I have committed a microaggression that I am not aware of, or if there's any way that you can feel more welcomed in our class, please let me know. And yeah, so to promote this atmosphere of mutual respect in this class, I think it's important to share your own experiences, your own values and beliefs, and to be open to the views of others, of course, to value differences and communalities, and to appreciate the opportunity we have to learn from each other. I think that that is one of the best parts of taking a class. And what we'll be doing, so I have been reading a book called Culturally Responsive Teaching in the Brain, and I actually worked on a project. I had a capstone project for a class that I took at Cabrillo College when I was there for 8 years. I did this class last year where I studied and looked at the ways that I can work to even out the equity of the students who are struggling in my class. And what I realized is that different students from different racially minoritized communities were not as successful in my class as my white students were. And so I wanted to figure out ways to form connections with students who are struggling in my class to allow for the brain to be able to learn with less stress and more oxytocin. And so what I did down here is I formed learning partnerships with students who were dependent learners in my class. And what I did was I noticed that students who had achieved a score less than 7 out of 10 on 2 of their first 3 quizzes in fall last year were not able to pass a class in the end of the semester. And so what I did was I reached out to those students and we formed learning partnerships where we got to meet face to face during extra office hours and just get to know each other. And in that way, we formed an asset-based profile for the students, and we just formed a relationship. We got to know each other, and we were able to build trust between us. And if you look at this graphic down here, if you're trying to learn information, but you're stressed and you don't feel welcomed and you don't feel included in class, and there were experiences from your past that have, been not so great in terms of education, in terms of dealing with teachers, then you're not going to be able to learn. Cortisol, that stress neurotransmitter, right, that stress hormone is preventing learning from happening. But when learning is trying to occur and there is connection, there's trust, there's a relationship, then learning can occur. And that's what I aim to achieve with forming learning partnerships with students. So mark your calendars for Friday 9:25 and Saturday 9:26. If you are one of the lucky people who get to meet with me and form a relationship and form a learning partnership, then we will be meeting on those days. And so I'll be notifying you as we get closer. And yeah, so questions on these learning partnerships or equity or anything, any suggestions you have or questions? Okay. So yeah, it depends on whether you sign up for the Monday lab or the Wednesday lab. If you sign up for the Monday lab, then you're going to meet on Monday for lab and discussion for Wednesday. If you signed up for the Wednesday lab, then you'll meet for lab on Wednesday and have discussion on Monday. Lecture is Monday and Wednesday.
Wait, I'm sorry. I'm a bit confused. So if we registered for CRN 74177, then instruction's Monday and Wednesday and lab is on Wednesday?
Lab is Monday.
Lab is Monday. So it'll be after instruction today.
That lab today is lab either day is 2:05 to 5:15.
Okay, got it. Thank you.
Mhm. Okay. That lab begins at 2:05. You voted for, lab was always at 2:05, but you voted on having discussion at 12:30. Discussion is at 12:30, 10 minutes after, 10 minutes after lecture stops. And that was a very close margin. The voting was like one more person voted for the 12:30 to 1:30 than voted for the 12:40 to 1:40. So we will have a 10-minute snack break and I guess eat lunch after discussion. So, okay. Expectations. So I wanted to go over these important things. And actually, before we do, let's have a little icebreaker. I'm going to place you into breakout rooms. And I know the feeling, if you don't feel like talking right now, I know the feeling because I was at a meeting on Friday and they kept putting us in breakout rooms and I was like, oh, I just want to listen. But it was good. I got to know some of my colleagues and you can do the same. So we are going to go into breakout rooms and write this down. I would like you to say your name, like introduce yourself. And I would like you to tell your members in your group what your superpower would be. And then if you've taken an online class before, have you taken one or is this your first online class? And if you've taken an online class before, please share a tip you have for your group mates to succeed, to help them succeed. Okay, so superpower, if you've taken an online class before, and if so, what's your tip to succeed? So I'll tell you, again, my name is Elizabeth. My superpower would be, I would be able to speak and understand any language in the world, like with just that. And then I have taught an online class, but only in the spring semester when we had to. And my number one tip that I just found out about recently, everyone listen up, is put your night light on your computer. Like take the blue light down a lot. And literally my brain, my eyeballs have been relieved so much this past week after I learned how to do that. So put your blue light filter on. Okay, so we're gonna go into breakout rooms, 3 per group, and I'll give you 2 minutes. All right, 3 to 4 people per room. Cool. Thanks everyone for coming back. I hope that was okay. I forgot to say, hi everyone again. Okay, good. Most people are back. Okay, good. Hi. I forgot to mention, I'm so sorry that you did not have to turn on your camera. I won't make you turn on your camera in lecture. In lab, I might need to see some work that you're doing, but in general, you won't have to turn on your camera. So I hope that was okay to get to know some of your fellow classmates. And let me share my screen again. So we have some questions about when stuff is. What you can always do is go to the homepage on Canvas, or the calendar in the mobile app also has your whole schedule there. I put it in the calendar, so if you ever have questions, you can go there. So on the browser though, you'll see something over here coming up. We have the discussion section at 12:30. That'll only show up if you're in the Wednesday lab section, because discussion is on Monday for you, right? So your calendar won't have all, it'll only have you. I separated it out by section, right? So like people over here that have lab to, or rather people here that have lab today, the 7-7 people, right? They won't see this discussion there. They'll see it on Wednesday, okay? So it's all in your calendar. All right. So real quick, again, let's do some expectations on Canvas. And okay. So I would love us to, look at this pact that we have, that we can share in the classroom, that things you can expect from me, and then what I'll expect from you. You can read through this. And I mainly expect from you to be active and participate in this course. Contact me when you have questions, and treating your peers with dignity and respect. And again, yeah, we are all learning about this technology thing and doing this online class thing. So give yourself grace. Give me grace, please. And let me know if there's anything else you would like to add to this list. Expect yourself to make mistakes. You can expect me to make mistakes. And I'll be, aware of that as well, that I'll know that we all make mistakes in here. And over here, I'll reach out to you if it seems like you need support. So especially with forming the learning partnerships that I talked about. And I'll be providing you with clear, organized instructions of how to succeed in this course. So having everything set up like it is in the weekly modules is my way of hopefully letting you know exactly what you need to do to succeed in this class. So going through the modules is your best way to make sure that you have everything down. And I'll be, striving every day to provide a supportive and safe environment for you to share and discuss your ideas with your peers, with myself. And I'll be here and actively present in your learning. So it's not just like, oh, you got to fend for yourselves, right? I will be here to support you and to offer any guidance that I possibly can. And also a variety of assignments. So I do like to incorporate different learning styles into my assignments. Visual learners, tactile learners, and auditory learners will all have a chance to, see or to experience material that is best for their learning style. Let me know if you'd like to see anything added to that list. So here's another bit of expectations. So you can hold on a second. Oh, let me see real quick. Maybe I posted it in the different course. Yeah, I did. I posted it in Chem 2. Oops. Okay, so I'll be putting this into Chem 1A. Anyway, so your classwork about outside of, or the classroom and Zoom expectations. This is what I'd like to start with here. So please use the chat to participate during lecture when I pose questions to class. So during lectures, I'll be asking you questions as we go along. Instead of just telling you the whole time, it'll be an active participation in the class. So use the chat, please, to answer those questions. And then please only ask questions when I open the floor to questions, because if you're asking questions as they come up for you, it can be disruptive to my flow and to other students, because you see the little chat box, the little chat icon blinking orange, right? So please don't don't ask questions until I open up the floor, and I will open up the floor. So please write them down when you think of them so that you don't forget. Keep your Zoom backgrounds appropriate. If you're going to use a Zoom background, make sure that there are no images that could be construed as racist, divisive, or hateful at all. I had problems with that with Confederate flags actually last semester, and it was a problem. So don't do that. Don't Make sure that your images, if you're going to have one in your background, are neutral and positive. Okay. And so here's other expectations. So I have an expectation, and you should for yourself too, about the 2-to-1 rule. So in college, you can expect to spend at least 2 hours outside of class for every 1 unit of class per week in order to succeed. So that means for our class, which is a 5-unit class, you should be spending 10 hours a week outside of class. So here's a schedule. You can, download this image if you want to start to commit, right? Designate 10 hours in your schedule to commit to working on Chem 1A every week. So make sure that you are able to do that to succeed. And it's really important to actually have a planner, take your calendar out and write down in your schedule when you'll do that, or online. I mean, on your phone or whatever. Place in your calendar, right, your schedule of when you will work on this class. There's also a rule called the 80-20 rule, where in college you can expect to receive 20% of class information directly from me, and then 80% from your own studies, meaning you'll have to go dig deeper, do problems, find definitions, read the textbook, right? Do the homework and all that to get the most out of what I'm telling you in lecture. It's the opposite of most high school classes, right? Mostly in high school, like, you don't have to study as much outside of class because the teacher tells you all the information you need to know. So just be aware of that. Also, your growth mindset. I expect you to, be thinking of this as we go through. I'm going to encourage and support your growth mindset, where you can embrace challenges, you can persist in the face of setbacks, you can see effort as with path to mastery. You can learn from criticism, and you can kind of think that you'll be able to grow and achieve more rather than be set back and stuck when you are in the face of difficulty. So also, you can expect me to support and encourage your academic mindset here. So these are the components of an academic mindset, as well as teaching higher on Bloom's taxonomy. So remembering, is good, understanding is good, but applying that information is better. Analyzing even better, evaluate and create. We'll do those things in lab this semester. Questions on the expectations? Good, we've had more people show up. Hello. Other questions? Okay, so we have so in this online class, right, academic integrity is especially important because I'm not able to watch you when you are taking quizzes and exams. So, or when you're doing your work, right? So please make sure that you are, you know, holding yourself accountable for academic integrity, right? Honesty in your academic work. When a quiz or an exam is open book, open note, that's great. But when it's not, I expect you to not get help from anyone or anything besides what you are provided on the quiz or exam. So please challenge yourself to adhere to these academic integrity rules. And here's the West Valley conduct and discipline policy. And here's some, tips and advice you can look at on this link here, some do's and don'ts. And so please be careful and aware of academic integrity in the online environment. All right. Last page I just want to go over with you right here before we get into lecture is the required materials. So you've all likely seen this before. There is the Books for Food loan program for the 6th edition of the textbook. You can do that and just borrow it, or you can purchase or rent that 6th edition, which is the most expensive, but you're also able to get the 4th or 5th editions, which are much less expensive. Just make sure that you're not, oh, what are we on? Chem 2, I'm sorry. Oh, yeah, okay, here. So that's for my other class, sorry about that. Our required materials are here. Okay, this is our textbook. Sorry about that, everyone. Chemistry and Molecular Approach. You can still, though, borrow it from the Books for Food loan program in the library for the 5th edition, which will be more expensive than the 4th or 3rd if you plan on buying them. We do have a free online textbook as an extra reference. So here, you need a notebook for lab, right? A non-graphing scientific calculator. And then you really do, it's really important to have laptop or computer access, like a laptop or a desktop access for this class. I understand that not everyone is able to have one. So I'm going to be working to make this class friendly to both people who have one or don't. And however, the library will be open this semester and you will have access to the computers there. Please just don't go into debt to buy one. And let me know if you don't have access to a computer and I'll make accommodations to help you there too. But there is still the free Surface for Food form or a program where you're able to check out a Microsoft Surface, which is a 2-in-1 tablet laptop, and you can borrow that during the semester. So you also have that option. So lots of options for you. I do recommend purchasing a chem model kit, and it looks like something like this, right? I have one here. That's going to be really helpful as we go through and learn about molecules and Canvas and all that. Okay, software, you need Zoom, you're here right now. And there's a great scan app, the PDF Adobe Scan app. I love it. It works great because you'll need to submit PDFs for your assignments this semester. So questions on required materials. So I think it's important to use the free textbook. You can try, you can try. I'll be posting homework. I'm not going to be listing problem numbers. I'm going to be actually posting homework. And I am going to be going in order of the textbook. I have this one here, right? The one that I have on the required materials. But as of right now, I can't think of anything that I'm going to be assigning from the actual book. I would just say that it's required because to succeed, it is so important. One of the important metrics that has been studied for success in the course is following the textbook in order. And so I'm not going to say I'm not going to force you to purchase it, but you really do, you should have it. Yeah. I mean, like I said, I'm not going to be assigning problems from the book. if I do, I'll be posting a PDF of what I'm asking you to do. But yeah, it's you know, I can't force you, you know. We'll go with that. Yeah. Yeah, the free one is supposed to be just an extra resource. And it's not that good. That's the other thing. The free one is not that good. There's a lot of mistakes in it, and it's not that good. But that's okay. For questions? Okay, so I'm going to stop my share, and we are going to switch to some demonstrations that I recorded last week that we get to watch together here. So I'm going to share my screen. Let's do this poll. Okay, so I've got this poll here. There are different things, different characteristics that have been shown to lead to success in chemistry. One is curiosity. Another is, you know, willingness to work hard. Another is calculation and curiosity. I mean, I already said that one. And imagination, having an active imagination. So let's see where we are as a class. So I'm going to ask you, how curious are you? It should show up for you on your screen. A through E. And this is how you'll see iClicker quizzes as we go through the semester as well. You're going to, so it's an active learning, right, method. You have you answering questions, and then we can see how the class did, right, where we need to focus throughout the semester. Any other people want to put the vote in here? How curious are you? If you're on a mobile device, do you see this? You should, right? Okay, good. I'll give you 8 more seconds. Okay. So cool, this looks like a distribution that I've seen before. This is pretty much what we have every semester. Lots of people are the most curious possible, right? And then the majority of the people are, you know, toward that end, but not quite. And so that's great. So let's do the next one. How hard are you willing to work to succeed in chemistry? Anyone else? Sweet, we got more people this time. More people willing to work hard. Good, good. All right. So great. 64% of you are willing to work your absolute hardest. And for the people who aren't, that's okay. Maybe things will change. All right. So we are going to now watch this video. So here are some demonstrations. Hello? Hello? Can you hear me?
Yes.
Okay. Okay, so what we are going to do today is talk a little bit about chemistry. Chemistry is everywhere. It's a demonstration that I do on the first day. And it's going to look like this. I'm going to share my screen. And in a second, we will see what's going on here. First of all, we're going to start with the candle. But before we even light the candle, we are going to talk about the chemistry of the matter itself. And what is cool about this demonstration is that it covers 8 main topics that we're going to be talking about this semester. Right over here, right? So we're going to get to those as we go through. All right, so first of all, let's talk about this candle right here. This candle is made of what? That's right, it's made of wax. And at this time right now, is this wax in the solid, liquid, or gas phase? That's right, it's a solid, right? And what we just called those were states of matter. We just said that the solid, liquid, or gas is the option for the state of matter. So we're going to talk about states of matter this semester. And in the solid state of matter, or the solid phase, we also call it, the molecules are really tightly attracted to each other. That is the characteristic of a solid, is that there are strong attractive forces holding those molecules together in the solid phase, really tightly packed together. And so those are 2 things that we're going to be talking about. So one of those, we said here, was states of matter. And again, those states of matter that we're talking about are solid, liquid, or gas. And we put them in parentheses because, as we'll see later, that's how we represent the phase or the state of matter in a chemical equation for a chemical or physical reaction, or chemical or physical change. And we also said that attractive forces are involved in these states of matter, and specifically for a solid, those attractive forces are really strong. Now let's go back. And what happens when we first light the candle? Let's talk about that. When we first light the candle, what do we see happening to the solid wax? Let's see. So we light the candle. I know you can't see it too well, but I can see eventually right now is when the heat from the flame starts to do what to the solid wax? What's that called? When heat disrupts the attractive forces of a solid. Yeah, that's called melting. And so what's happening right now is the heat from the flame is melting the solid wax into a liquid. And so is that a physical or a chemical change? When the wax is changing from solid wax to liquid wax. That, yeah, is a physical change because the wax isn't changing composition. The wax is just changing phase, or it's changing its state of matter, but it's still wax. And then another thing is happening when the liquid wax gets attracted, right? There's attractive forces from between the liquid wax and the wick. And that's what we call wicking, right? We call it a wick. It's wicking the liquid wax up it via the attractive forces. And then when that liquid wax finally gets hot enough, it vaporizes into the gas phase. And so that, again, from liquid to gas, is that a chemical change or a physical change? Yeah, it's a physical change because it's still wax, it's just getting vaporized into the gas phase. Now, once that gas is vaporized, then that is when combustion or burning happens. That is what is sustaining the flame right now, right? So that combustion or that burning, that is a chemical change. That is when something changes in composition. The actual chemical formulas, as we'll see, change for a combustion. And so this is what we're looking at over here. And we've got a candle burning on a stir plate, and we'll get to what the stir plate is for in a second. And let's write down those other topics we just mentioned. So we said that physical changes occur. Right? And that is when the state of matter changes, right? We said the solid wax melted into a liquid and then vaporized into a gas, right? We said chemical changes occur in this example as well. So the chemical change in our example for the burning, right, of the candle is combustion, AKA burning, right? And what happens here is the vaporized wax, meaning wax in the gas phase, plus what? What is required for burning to occur? Combustion. What's the other thing, the other reactant for this chemical change? For burning to occur, right, we need oxygen from the air, which is gas. And we know this is a chemical change because the products are different compositions. We don't have wax and oxygen anymore, but we do have carbon dioxide. So chemical changes are something that we'll definitely be talking a lot. I mean, chemistry is all about the chemical changes. Physical too, but really, we're going to be doing lots of chemical changes as well, right? And we want to also mention, right, another very important part, the other product, energy. Energy is produced, and that's what we see over here in the flame, right? And so we will have a whole lot of talk about energy this semester, which is involved in every chemical, every physical change all around us, right? So these, right, are gases over here. And we're also going to be talking about gases this semester. We have a whole chapter on gases. And so now the question remains. We want to, since we're scientists, we are chemists, we want to prove that actually, in fact, oxygen is required and that carbon dioxide is a product and water vapor is a product. We can definitely see the energy, right? We can see the flame and we can feel its heat. But right now, we can't tell that oxygen is required as a reactant or carbon dioxide and water vapor are products. So what we're going to do is come back here. And the way that we can do that is now I'm going to take this beaker and I've got some things in it. I've got a stir bar, that's what's spinning right now, so that we can get a good mixing of the contents. And this in here is a solution. It's a solution, it's a mixture. It's a mixture of deionized water and a base that is sodium hydroxide. And we're going to talk about acid-base chemistry this semester as well. Right now, how do we describe this mixture, this solution? Right now, what color is it? If you said clear, remember that clear is not a color. Clear tells us something about the clarity. So it is clear and colorless. So from now on in our class, make sure that we're talking when we see something without any color and it's clear, we have to say clear and colorless. But I can make a chemical change occur with this indicator. This is an indicator that tells us that the solution is basic because when I add the indicator to the basic solution, the indicator turns pink. And so that is also an indication that a chemical change has occurred. All right. So what we said we need to do is make sure that we can prove that oxygen gas is required for the chemical combustion to occur, the chemical change, and that carbon dioxide and water vapor are formed. So what we're going to do is place this big beaker right on top. It's a 2-liter beaker, and so we're going to close this system. And let's see what happens. What do we start to see happening over here and on the walls? It's getting a little cloudy, right? What is that, do you think? Yeah, that is the condensation, which tells us that water is produced as a product in this reaction. Ooh, and what just happened to the flame? Right, it went out. So that tells us that oxygen was required for the reaction to occur as well, for the chemical change. And so we're going to keep this going. I'm going to share my screen. We're going to put those up. All right, so I'm going to put on here solutions, because solutions are also going to play a big role in our course this semester. And I'll draw the big beaker that we placed on top of these items with our little beaker, 50 milliliter beaker inside, and our solution. So before any combustion, rather before, in the beginning, right, we saw that the water, H2O, plus a base. What color was it before? Right, it was pink. Oopsie. Right, and we also saw evidence of gases being produced, because from this candle, right, we said that we could see right, water vapor depositing, right, on the walls of the beaker. So that's what I'll draw over here. That water vapor went from gas to a liquid. So is that a chemical or physical change for the water vapor condensing? Right, that is a physical change because it's still water. It just went from gas to liquid, right? And then we also saw that the flame went out, right? So that was evidence of the oxygen gas being required for the reaction, right? And then what did we see happen over here, right, in the small screen to the contents of the solution, right? The indicator went from pink to what? Right, we saw it colorless. Changed to colorless. So that must have meant that a chemical reaction occurred. And I'll tell you what that chemical reaction was. The evidence that we have for the carbon dioxide being produced is the fact that that color change in the solution occurred, because carbon dioxide reacts with the water in the solution to form an acid, right? And this acid neutralizes the base. So this is actually a neutralization reaction or an acid-base reaction. We're going to talk about acid-base chemistry in here this semester, right? So this is how we could tell that the carbon dioxide was produced, right? Okay, so this happens to be a pretty deceptively simple situation that we have going on here, right? There's a lot going on, a lot to think about in such a simple demonstration. Okay, and it turns out that this reaction right here, this whole system that we have going on is actually a model for a real world problem. This is a real world reaction occurring right now in the bodies of water and especially the oceans on this planet called ocean acidification. Okay, so what we just showed over here, right, is what's going on in the oceans where carbon dioxide from fossil fuels is reacting with waters in the oceans to form acid, which is making the oceans more acidic or less basic. So this happens to be a very instructive demonstration, and not only that, but a little model for a big problem. All right, so we're gonna go to the next demonstration, demonstration number 2. And we call demonstrations demos. You'll always hear me talking about demos. All right, so we're gonna stop here and I'll show you the video. Okay. So we're back. And what did we see happen? We saw, right, propane in a balloon react with oxygen from the air. These, by the way, are the reactants in this chemical equation. Right? And these are the products over here. So it's still a combustion. It's another combustion. Right? We still had carbon dioxide and water vapor and energy being produced. Now, the question is, after we saw and heard that combustion, can we say that the energy was released or absorbed? What do you think? Question over here. Was the energy released or absorbed from that combustion? Yeah, released, right? Since we saw it, we heard it, I definitely felt it, we know that the energy was produced as a product, right? So whenever anything is a product, it's been released. Right? So the other question over here is, are the products lower or higher in energy? Right? Are the products lower or higher in energy? All of these over here. Since energy was released, do these products have less energy than the reactants or more energy than the reactants? Are they lower or higher? If you guessed lower, you were correct. Because in order to lose energy as a product, the products that are left over, the chemicals that are left over, the substances, had to lose that energy. The energy had to go out somewhere. So that means that these products here are left over with less energy than the reactants going in. And we're going to talk about that a lot more as we go into our thermochemistry and energy and chemistry chapter. And there you have it. Thank you very much. Hello? Hello? Okay, so cool. Thank you for watching those demos. One thing that I forgot to mention for the ocean acidification, for that model for ocean acidification, the reason that that's bad is because more acidic oceans lead to less availability of carbonate in the ocean to form shells, because shells are calcium carbonate. They are made from carbonate, and so the more acidic, the less carbonate available for shells, for mollusks, as well as coral skeletons. So that's why we're seeing weakening of shells and colony collapse for oysters, for example, as well as problems with corals. So yeah, so I hope that that was instructive a little bit. We're going to be going over lots of those things this semester. Are there any questions that you have? What questions do you have about those demos? Yep, we'll talk a lot about energy in this class. Questions? Higher energy to lower energy, that is the natural flow of things, yes. That is favorable transition from high to low, yep. Energetically favorable. Okay, so I'm going to share my screen over here again. And we will start taking some notes. So, we've got another 10 minutes. We'll see how far we can get. And then during lab today, that's when we'll continue as well. All right, so we're going to begin with the definition of chemistry. We're all in chemistry class together here. How do we define it? Not yet. The worksheet I sent, so we probably won't actually get there. It's looking like we will continue with that worksheet I sent you in the Canvas message earlier. We'll do that in lab today. Thank you for asking. Yeah, so we're not on the worksheet yet. But who can give me a definition of chemistry, one that works well? We have the study of matter. And what do we have to study in order to study matter? Do we just get to look at it on this macroscopic scale? Right. Atoms and molecules, exactly. Masha and Rajeshri, right? So we are going to be able to, we're going to have to study the atoms and molecules, right? Behavior of atoms and molecules to study matter. So understand matter. By studying atoms and molecules. Right. And so what do we mean by matter? What's matter? mass and yep, mass and volume. So it has mass and takes up space. I like to call it stuff. Stuff with mass and volume. All right. Cool. And what are atoms? How can we define an atom? Yeah. Yep, particles are matter. Yep, particles are stuff. Well, not all particles, but the ones that matter, yes. Particles of matter are stuff. Yeah, so they're particles. And yeah, we can call them the building blocks of matter. The building blocks of matter. And what are molecules? Yeah, a combination or a group of atoms, right? A group of atoms, I like to call it a group of atoms bonded together. And we'll learn about the type of bonding that occurs in a molecule. Okay, cool. So, good. Let's watch the video that is in our modules. In the About Our class. Because if you haven't seen it, I think it's a great kind of zooming in look at what we mean by studying the atoms and molecules of matter. And you can see on the bottom that the scale of the size, right? Down below. Someone said too loud, but there wasn't a sound to that video. So. Okay. Okay. So let's see, in the next 2 minutes, I'm going to continue down here. The audio was coming through? Okay, cool. So it wasn't for me. Oh, that's why. Okay. Sorry if it was too loud. All right. So good. I'm glad there was audio for you. Okay. So in the next 2 minutes, just real quick, let's just introduce the scientific method. How do we study this matter? Right, we use the scientific method. Right. And the scientific method involves formulating, or rather making observations, right? Using the senses or measuring instruments. I'll be posting these notes, and so you can get these images from the notes there, right? We can formulate a hypothesis, which is a tentative interpretation or explanation for your observations, right? And then we do experiments, rigorous experiments using very accurate measurements in order to either confirm, right, or prove false the hypothesis that we made, okay? So we do testing, right? If we confirm, we can make more hypotheses. And if we see lots of observations over time, again and again, if we see observations that occur again and again over time, then that can lead to the formulation of a law. So a law is a summary of observations that happen again and again. Okay, so I'm going to have to stop there. And again, these notes will be posted, and we are going to pick up where we left off in discussion today. And we'll get practice with learning how to classify matter. So let me know any questions you have over the Canvas inbox, and I'll see you in discussion if you have discussion today. And I will see you in lab if you have lab today later on. So thank you so much, and I will see you soon.